All right. And to everyone out there in TV land, thank you for joining today. You could be anywhere in the world and you're here with us, so we appreciate that. So, my name is Jovonni, and I'm the Developer Relations Engineer here at Agoric. And I've been engineering for about 15 years, been building in Web3 since 2015. So, I love this space. And today, what we're going to do is we're going to be walking through writing asynchronous cross chain smart contracts. And what does that even mean? Okay. Okay. There we go. So here's today's agenda. So first thing, we're going to start with the cool stuff. So we're going to do a demo of a dApp template that you can go use today. This is actually available here, GitHub Agoric /dApp Orchestration Basics. And in here, there's a bunch of stuff. You can come in here and follow along if you like. I'll try to set this up, but we'll be walking you through a demo of that. Then we're going to backpedal a little bit and start talking about some Agoric concepts that's used in this. And then we're going to walk through the code of the project itself, mainly the smart contract, but we're also going to show what the UI is doing as well. All right, so first things first, let's be grateful to the universe and hopefully it's gracious to us today because this will be a live demo. So actually, before I do anything, let me show you what the environment is like. So here we have a Kubernetes environment. Let me zoom in here on the right. So if you look on the right here, we have a few pods, right? So we have an Agoric node, we have a Gaia node, and we have an Osmosis node. Then we also have these 3 Hermes relayers sitting in the middle, which is going to help us do some cross-chain stuff. And on the left here, all I'm doing is pretty much just making sure our relayers don't let the channels don't expire, making sure they stay active. Okay, here's the logs for the actual Agoric node, just in case we need to debug something. Okay, so first things first, this is the dApp. And what we're going to do is we're going to first connect our wallet here. And I want to note that we are pointing to Agoric local here. And so, okay, first things first, let's create what's known as an orchestration account. And this first orchestration account we're going to create is going to be for Agoric. And so let's look at what the transaction is that we're signing. So here we have this notion of a parameter, an offer argument, and we're passing in this chain that we want to create an orchestration account on, which in this case is Agoric. Then what we're showing here is this is the invitation maker that we're invoking to get an invitation. And we'll talk about what these mean. Okay, so let's approve that. Let's hopefully, and if this doesn't work, we have a, okay, work, boom, cool. So we have our first orchestration account here. And now this is an independent account, not yours, but it's owned and controlled by the contract. And so just like any regular account, what we can do is we can, let's say, send some funds to this contract, to this address, right? So this is just a typical bank send here. And so I'm gonna send some funds here. You're gonna see some funds pop up. This is just while we're debugging this, if we want some of our accounts to start off with funds before we do anything. And also I can send it another native denom, right? So here we have interstable token or IST that we're gonna send it. Okay, so this is an account that exists on the Agoric chain. So now let's do something a little more interesting. Let's use our contract to now create an orchestration account on another chain. So here we're going to see the same structure in our transaction, but you see here where the offer argument here is Osmosis instead of Agoric. But I want to point out something else here. If you're, for the devs, if you're interested, here's the type URL when I submit these wallet spend actions. And let me see. Yeah, here you can find a few things, but once again, this is the invitation maker. We're using the same invitation maker we just did. Okay, so let's do that. Hopefully the universe is gracious to us today. If not, we have a video. Okay, cool. Offers accepted. Boom. Perfect. So now what just happened, in an asynchronous way, we just created an interchain account on another blockchain. In this case, it's Osmosis. And so we could do the same thing here, right? We can fund it the same way that we did before, right? Just send my actual transfer, but this would be a different type of transfer for those interested. So if we look at the type URL in the transaction we're signing, you see this is an IBC transfer, not just a native bank transfer. And so you see the receiver here is an Osmosis account, and it's coming from this Agoric account. And here, this is just saying what the channel is that we're using. This is related to the relayers that we're running, etc. For those, and we could probably do a whole series on just that alone, right? But that's another time. Okay, so now let's approve this. So now what we're going to do is just send an IBC message and this or IBC transfer. And now what we see, I sent BLD, but we have this IBC denom here. It's not BLD. When similarly, if I send, let's say ISC, which is another native asset, we will get, as expected, we would get another IBC denom here. Okay. All right. But so up until now, what we've done is we've created accounts, we've funded accounts all manually though, right? So let's do some magic. Let's use the orchestration API in our contract to now do these steps in one offer, right? So what's going to happen is we're going to sign one transaction, and this transaction is then going to create two ICA accounts, or two orchestration accounts, I should say, one on Agoric Local and one on Osmosis. And then we're going to the transaction, we're going to attach some funds to this offer. And these funds that we attach are then going to get deposited into our local chain account, which is then going to trigger an IBC transfer, all in asynchronous manner in one transaction. Let's do this. So we're going to keep Osmosis selected here, and we're going to select fund new. So a few things change. So first thing is, you see we're attaching funds here. Oh, let me actually show this. So really quick, let's look at our wallet. We're super rich, right? So in our wallet, we have a few funds, right? So in there, we have BLD. So what we're going to do here is we're going to attach some BLD, which is arbitrary amount, to this offer. And we're going to pass in the offer augurs osmosis again. But one other thing that's going to change is the invitation maker that we're using is not going to be the make account invitation. This is going to be another invitation maker. And we'll show this in the code in the second half of the workshop as well. Okay, so let's do this. And let's pay attention to the screen. So what's going to happen here is we're going to see a few things happen without me doing anything else. Okay, so we saw an account pop up. Okay. We see two accounts pop up. Interesting. One has 500 now, 500 BLD. And the other one now has some IBC transfer. Magic. What just happened is, like I said, we just created two ICA accounts, or two orchestration accounts, one local account and one remote ICA account or interchain account. And then we deposited half of this money into the local orchestration account. And then we triggered an IBC message to the remote orchestration account with the other half of the funds. And so this is showing all of the manual things that we just did on screen happening in an asynchronous manner, all in a contract. Okay, so thank you to the universe for letting us go through that without any hiccups. So now let's continue. And once again, you guys can follow along and try this yourself. And okay, yeah, we'll continue. So, okay. Oh, and also the slides are going to be available here at this discussions link. Just not posted yet. All right. A high level, what is Agoric? Agoric is a smart contract platform. In Agoric, we write contracts in JavaScript, a more secure JavaScript, I should say. And we also implement this paradigm called this object capability security model, which we'll talk about a little bit. And we also use hardened JavaScript. This is key. And recently we've released this orchestration API, which allows us to do, as you just seen, complex cross-chain interactions in a convenient, easy way for developers. So we just did the demo. All right, let's go through some fundamentals here on what we just saw. So first off, what are object capabilities? For the programmers in the room, you're familiar with object-oriented programming. So in object-oriented programming, just imagine if you have access to an object, then you can invoke any public method on this object. And in object capabilities, if you look at this graphic on the right, these three nodes are objects. The edges there, those are references. So you see, Alice has a reference to Bob and Carol, but Bob does not have a reference to Carol. But because Alice has a reference to both, what Alice can do is she can invoke this greet function on Bob and pass Carol as a reference, therefore allowing Bob, by being granted permission or the capability to do so, to invoke Carol now. And so as a developer, just think about if you're writing code and you are writing a higher order function. And a higher order function is a function that returns a function. So if you have a function that returns a function, whoever is receiving the return value of that, they can invoke those or call those functions that will return to them. But if a function isn't returned to them, then theoretically they don't have anything to invoke there. So this is the concept, right? And it's I'm not going to say an older concept, but it's definitely something that has been around for more than a little bit of time. If you're interested, it's a very interesting rabbit hole. We'll give you some resources if you're interested, just ping us. Okay, so this moves us on to hardened JavaScript. So we have two sides here. On the left side, you have conventional JavaScript without using hardened JavaScript. And on the right side, you have hardened JavaScript, us using hardened JavaScript. So on the left side, you see we have this function, and this function returns an object with two properties, get X and get Y. So what we can do in regular JavaScript is if we call this function and we assign this to some variable, this p11, what we can do is we can assign a value to p11.getX, therefore overriding this property. But if we use hardened JavaScript, you see the difference on the right side is we're returning a hardened version of that same object. When someone who's consuming this tries to overwrite this property, they then get an error. Because what hardened JavaScript is doing, as you see here, is it's doing a deep form of object freeze, which makes properties of an object immutable. And also in Agoric, we have this concept of VATs. And so for the developers out there, a VAT is, just think of it as a isolated JavaScript environment. And when you're writing in anything like Node or something like that, you have these same properties in your environment. You have an event loop, you have a message queue, you have a stack, and you have a heap. And so what's important here is to keep in mind that contracts that you write on Agoric run inside of their own VAT. And if you think about what is a VAT, just you see the image on the bottom right, this notion of if your brain was in a tank and it was wired up to a computer, how would you know that you're an actual person and the computer isn't tricking you into thinking that you're a person, right? And how did you know that your brain is in a VAT, right? This isolated place. So these are two key things, though. So all synchronous communication is only within a VAT, and all communications between VATs is async. But of course, it's just JavaScript, right? So you can always just do async communication within a VAT, making promises, etc. Okay, so then the question becomes, how do you have two VATs communicate with each other? And typically, similar to browsers, how browsers use fetch for remote communication, in Agoric, we achieve this with E. And so all E is doing is asynchronously invoking methods in another VAT, machine, or blockchain, depending on how it's used. And so let's now talk about what we call Zoe. And so Zoe is this on-chain escrow enforcer framework that is providing a way for developers to write contracts without having to worry about something we call offer safety. And so what offer safety is, in a nutshell, is if you have two people who want to make a deal, this is a concept where it guarantees that if I want to make a deal with somebody, whatever I want out the deal, I either get that exactly or I get back what I put into the deal. So in Zoe, we have this concept of an offer, a proposal, an invitation, and a seat. Let's briefly look at what these are. So first, let's look at just an overall flow of Zoe. So here on the bottom, we have these two parties who want to make a deal by submitting an offer to a contract. And so the first thing that they're going to do is they're going to escrow their assets with Zoe. And then what they're going to do is they're going to communicate with this smart contract, which is then in step 3 here going to run this custom behavior. If the smart contract's logic is happy, then according to what the developer wrote, then the smart contract is going to signal to Zoe to reallocate the assets that were escrowed with them. And then the smart contract is going to signal to Zoe, hey, the offer is complete. And then at the end, in step 6 here, the two parties who were originally in the deal, now they can ask Zoe to get their payouts from the deal actually being successful. And also one thing I want to point out here, and you see it's in the second bullet point here, is another way that Zoe helps mitigate risk for developers is Zoe, remember we talked about these VATs, Zoe runs in its own VAT on chain, in its own isolated environment. So imagine you having this thing helping you do escrow for security reasons and to guarantee offer safety, and it's running in its own isolated JavaScript environment. Okay, so Zoe also has this concept of an invitation. And so TLDR with an invitation, you use invitations to submit an offer to a contract. And so these invitations, they are created within the contract by Zoe. And we'll actually show you how this is used too, because everything I'm showing here, you're going to see in code. Okay, and so here we also, Zoe has this notion of seats. And so a seat, think about a seat as two different perspectives of the same thing. And so we have two different types of seats. We have a ZCF seat, so a Zoe contract facet seat, which is a seat representation that is used inside the contract in the offer handler. And then you also have a user seat. And so this user seat is given to the entity that's making the offer. And this user seat, you can use it to get payouts, etc. And you'll see how this is used as well. Okay. And then now we have, let's talk about this notion of a proposal. Proposals have these three keys, right? So you have this notion of a give, a want, and an exit. And so a proposal, when you're submitting an offer to a chain, to a contract, it has a proposal. And the give key is the key that represents what you're offering up into the deal that you want to make, or the offer. And then the want is what you expect to get back. So you expect Zoe to have reallocated this want by the end of the deal or the end of the flow. And then this exit is something optional that you can define to declare how you want the deal to end, where you can either end it on demand or you can end it via an expiration, etc. Okay, so to summarize this, as I said, these things make up an offer. So an offer has an invitation, a proposal, payments, and offer arguments, and we'll see these. Okay, so now let's talk about something called an EXO, which you'll also see here. An EXO is an exposed remotable object. And so just like how we have E for an eventual send, Chris loves to say it this way, and I love it. Think of an EXO as an eventual receive. And if you think about the graphic here, this graphic is of an exoskeleton. It looks pretty cool. And here's the analogy. EXOs have these two properties of them. You have this notion of an interface guard in an EXO. You also have a method. So if you look at the exoskeleton, you could think of an interface guard as the outer protective layer and the methods as the inner part of the exoskeleton, like the human or something like that's actually being protected. And we'll look at what the interface guards look like, et cetera, how you define methods too. But just a high level flow really quick. Here, let's say if a user wants to asynchronously invoke this add method using E, then what the interface guard is going to do is it's going to verify the method signature on the inputs. And then if that is happy, then it's going to actually invoke the method. Then on the way back, on the information path back, the interface guard is also going to verify the return types, et cetera, depending on how you define it to be. So if the interface guard is happy with how it's being called and how the data is being returned, then the interface guard is happy. Then the result comes back to E, therefore back to the user. Okay, and almost done here with the slides. So also storage in Agoric works in the way of the following. So in our Cosmos SDK, we have a Cosmos SDK module that we wrote called VStorage. This is using the IAVL storage that is typically used in keepers, etc. And what we've done is we've built this hierarchical data storage structure where you have these dot separated segments to define the storage path. And on the right here, this is just a representation in the browser of using some tool that we have that allows you to view the storage contents of a node that you point to. And we'll look at this visually too here. But two things is key, and we'll show this in the visual next. VStorage is write only for contracts, and VStorage is read only for clients. And let me show you how this looks. So on the right here, you have this contract. In the middle, you have VStorage. On the left, you have an actual client. So on the right, we see that the contract is invoking this set value method using E asynchronously on this storage node. And so all that's doing is just setting a value at that node in the tree. And so when you create a contract and you pass a storage node to it, that contract can now store information at that node and children to it. Okay, and then on the left side, so you see that's write only from the contract. On the left side, now you have a client that is invoking VStorage via RPC to get the actual value. And we'll show you how you do that from the front end as well. Okay, So now let's move into a few orchestration concepts to wrap up the slides here. So the first thing we have is this orchestrator that you'll see. We also have these chain objects that we're using, and we have these orchestration accounts, which I've briefly hinted in the demo there. And the orchestration account, like I mentioned, you have two children of this class of orchestration account, right? So you have the local account and you have a remote account. And the remote accounts are interchain accounts for now. Okay. And for those of you who don't know, it's a super nice rabbit hole if you're interested. But an interchain account, if you're interested, look up this ICS 27. But TLDR, just think of this as a way to allow one blockchain to control another blockchain through using IBC. And this is the whole rabbit hole, but it's a really nice one. Okay, so done with slides. Awesome. Now let's look at some code. That's why you guys are here. That's why people are here. Okay, oops. All right, so now I want to show one thing. So first things first is, and this could probably be a whole nother workshop, but what I did before this session is I deployed this contract using our process, and just high level for people who are listening. If you think about the Solidity world or the CosmWasm world, in CosmWasm, the way you install a WASM artifact on chain is you install it first and then you make an instantiation from it. Our approach is somewhat similar, right? You install this bundle on chain and then you go through some governance to actually deploy or make an instance of that contract. Okay, but this is just showing the proposal after it's deployed. All right, so this is the one half of the meat, I would say, of this contract. Okay, so this is the orca.contract.js. Actually, let me show you some folder structure first. So when you want to look at dApp orchestration basics, what you're going to have is you're going to have a few folders. So the contract folders obviously going to contain your contract information and all of your artifacts, etc. Just think of it as its own node project. And we also have this UI that we just showed you. So in the contract, in source, you have these two files. In source here, you have orca.contract and you have orca.flows. Okay, so let's first walk through orca.contract. So let's look at our imports here first. So first, we're going to import this shape from ERTP. This is going to just allow us to think of it as like a structure that we want to make sure some variable that we're being used is pretty much adhering to this structure. We'll walk through that a little bit. Here, just make traces for some logging stuff. This with orchestration, think of this as like a way for us to wrap our main entry point with the tooling that we need to do some orchestration stuff. This invitation shape is similar to the amount shape. This is just, every time you see the word shape, just think of it as like this structure that we want to make sure something adheres to later. Then we have this matcher, which we're going to do a bunch of cool stuff with. And then we have these flows, which is the other file that we showed you. And we'll show you what these flows have here. But TLDR, these flows have our handler functions. Think of them that way. Okay, then we end just importing some types here. Okay, so here we're doing setting up some logging for ourselves. Okay, so here's the first shape that we're showing definition of. So what we're saying here is whenever a proposal comes in, we want that proposal to have the amounts should adhere to a certain structure. So what we're saying here is we're saying that the keys in this should be of string and the values of those keys should be of amount shape, which is what we're importing up here. Then here we're defining the number of properties limit that these should only, and hence the word single amount record, these should only be single amounts that we're expecting to the contract at any point in time. Okay, now we're doing some more interesting stuff. Here we're just defining a shape of, we call them powers, but these are, think of these as resources that the contracts use to do a bunch of cool things in Agoric in general. And so what we're saying is we want to have this specifically, these copy records that have these keys, and these keys, their value should be remotables with these names. Then here, okay, so if you think about Solidity or CosmWasm, in Solidity you have a constructor, in CosmWasm you have instantiate. In Agoric you have, let's look at the bottom here, we export this start here. In the start, we're wrapping with this with orchestration. And the parameter here is this contract. And also you see we're hardening this, by the way. Remember what harden is doing. So here we're passing in this contract here, right? So this contract is actually where everything starts, but this contract is the entry point. So when we deploy the contract, what you do is you see this function run here, okay? At contract creation time, we can define something, we can pass something in what we call private arguments. And these private arguments, they are available to the contract at contract creation time. And so here we're just defining what the shape should be, that it should be these orchestration powers that you see here, and that it should have this other property here that has this marshaller. That's also remotable. Okay. Then we're hardening that there. Okay. So you're going to see hardened a lot everywhere, right? So just going back to what we saw on the slides. All right. Time check. See. Okay, good. All right. And so now let's look at what the contract entry point is doing. So let's look at the parameters first, right? So first thing is we're passing in the Zoe contract facet so that we can use it to do things later. And then here we're passing our private args, which we talked about. And here we're passing the zone. This is the first time you see this zone here, but remember how we talked about exos? So we use zones to allocate exos. Think of it that way. And here this is just some orchestration tooling for us here. And so we'll look at what orchestrate all is doing. So what I'm doing with orchestrate all is I'm actually passing in guest functions here and host context. And so what I get in return, I'm destructuring these 3 offer handlers. And these offer handlers we're now going to use in setting up so that somebody can invoke them. Okay, so now what we're doing here is we're defining an exo. And this exo we're calling public facet. And so what this is doing is we're going to, so let's think about what a facet means, right? So a facet, if you think about like a gemstone, so a facet, think of it as like if you think about like a diamond, the flat parts of the diamond so that that allow you to peer into the fineness of the diamond, those are called facets. And so the same thing happens here. If you see here on line 115, let me make the codes bigger actually. Hopefully that wasn't too small for everyone in the audience. My apologies there. So here we're returning this facet here, which is allowing the outside world, outside of the contract, to invoke it. And that the invoker could be another contract. It could be someone submitting a contract to the chain, as you've seen. But let's look at what we're doing in public facet. So we're defining an exo here. And so the first thing we're doing is we're naming our exo. Second thing is now we're defining an interface guard for it. So remember remember interface guards think about exoskeletons, right? So this is the exoskeleton part. So what we're doing is we're naming the interface guard here. And then we're saying for this invitation maker, we expect that to be invoked with no parameters. This could also be something like m.string, right? And this would pretty much say, I expect this to be called with a string as a parameter, right? And we use these matchers to define this here. Okay, so for each of these, we're expecting no parameters here on the make invitations, but you can if you wanted to. But the return type here, remember we imported this invitation shape here. And so all we're doing is we're returning invitations, or we're returning something that fits the shape of an invitation, to be concrete. All right, so that's the exoskeleton part, right? So now let's look at the inside of this interface guard, or exo, I should say. So here we have the methods that are going to then return invitations. So let's look at what these are doing. So when we looked at the demo earlier, you saw that I was making one account at a time. Remember I showed you that I was calling the make account invitation maker. And so what happens here is this is going to use ZCF, right? The Zoe contract facet, to make an invitation. And we're going to, the method here is the offer handler, I should say, is going to be this offer handler that is destructured from invoking this orchestrate all. And okay, then on the second one here, we're going to do the same, but we're actually going to pass it a few more parameters. So what we're also going to pass it here is what we expect the proposal shape to be, right? So here we're saying, let's return an invitation for this other offer handler, this make, create, and fund. And we're going to expect this is the optional parameter, but we're going to expect the proposal shape to be to match this specific key here. So we don't want a give in here, but we also want the value of that give to be a single amount record that we defined earlier, right? Okay. All right. So this is the actual, like, how we get the contract like started, set everything up so it can be invoked. But now let's look at the meat of it. Remember, recall at the top, we have this flows here, right? We're importing these flows here. And so these flows are all of these, everything that we export here. So let's look at this really quick. Let me go back. So if you look here, orchestrate all is where we're using that flow. So we're passing in these flows as guest functions with some host context. Okay. So here at the top, we're using matcher again. And here we're just using this for logging. Okay, setting up some logging here with make tracer again. All right, so now let's look at using the orchestration API concretely. So we're going to walk through every line here. So this is our offer handler. Let's look at the parameter types here, right? So we have this orchestrator here, and we have this context, which isn't being used in this handler, but we use it later. And then we also have the ZCF seat. And remember, I said that seats, you have a ZCF seat and you have a user seat. And a user seat is given to the offer maker, and a ZCF seat is used from inside the contract. So that's what this seat is here. This is a ZCF seat. Okay. Then we have these offer args, and here I'm expecting these offer args. Remember from the UI, I showed you that when we are sending an offer to the contract, that we have this chain name that we're passing as a string. That's where we're defining this. So here we're saying that we want the offer is just another, typically like in Solidity, you might write something like require if you want to do something like this, depending on what you want to do. But all we're doing here is we're saying that the offer arg needs to match a copy record that has this key, and the value associated with that key needs to be a string. Okay, we've seen that approach in the other file. But that whole using matcher to do things like that is commonplace in Agoric contracts. So just keep that in mind. So here we're just destructuring chain name, logging some stuff out. Okay, and so here you see the use of seat.exit. And the only reason why we're doing this is because this handler is not exchanging assets at all. So keep that in mind. All right. So now what we do is now you're starting to see the use of the orchestration API. So we're going to use this orchestrator that we pass in here. And we're going to invoke now this function called getChain, or this method called getChain. And this, we're going to pass in this string of chain name to it. Then what we get back, oh, I want to point out, notice that we're using await here. Remember the title of the talk, right? Writing asynchronous cross-chain smart contracts. So we're using await here. This is actually going to go do something asynchronously, and it's going to return to us a chain object. Then we're just logging that out. Then this is where the magic really happens. So here, notice we're using await again for asynchronicity. Here, we're taking that resulting chain object, and now we're making an orchestration account. And so if I pass in Agoric as the chain name, then this make account is going to return a local orchestration account. But if I pass in Osmosis or another chain, it's going to create a remote chain account. And the creation of that actually involves sending a cross-chain message to that chain, and the relayers having to relay that to get acknowledgements and inits, etc. And this being able to do that using await here is actually really useful. Okay. And this is just the most hello world that you can really do with the orchestration API. So here, finally, what we're doing is we're just going to return this chain account as a continuing offer so that we may be able to use it later. Also, again, just to point out, notice here we're using hardened again to harden this entire handler. Okay. So now let's look at the second method that we called. Let me make this bigger maybe. Okay. So let's look at the parameters here again. And remember, actually, let me go back to the UI. So remember what we did here is we invoked this hello world. Oh, what happened? Oh, sorry, I've been talking so long the wallet timed out. Okay. So remember here, when I invoke this make create and fund, notice I'm calling this make create and fund invitation here, right? And this make create and fund invitation, that is here, right? And here, This is the offer handler that it is for. And then that offer handler is here, just to make it all make sense. Okay. So here we have an orchestrator again, and here we have some context. But now we're actually passing in some context. And then we have a seat again, and we have some offer args. The type of the offer args is the same. We're just expecting a key and a string, key of chain name and with a string as the value. Okay, so a few things have changed here. Let's look at this. So on line 61, which is we're invoking this get proposal method on the seat. And so what this is going to do is it's going to return to us the proposal that is being sent to the contract. And let's see. So here you can see the contents of the proposal here. But in here, what I really am interested in is, remember how we had how proposals have give, want, and exit optionally? Here we just want the give key here, because all we want is what assets did the caller give us in this offer. Okay. We're just gonna get the first two values here, the key and the amount. So now let's look at some cool stuff. So if you look here, all we're doing is waiting for all of these promises to resolve here. I'm going to destructure this to Agoric and chain. But what's happening here is we're using this orchestrator to invoke get chain, and we're passing in Agoric. Therefore, this is giving us a local chain account. And then here, what we're doing at the same time is we're using the orchestrator again to invoke get chain to pass in whatever the other chain is, right? So this would be a remote chain account or remote orchestration account. Okay. So then what we're doing is we're using this chain object to invoke get chain info. And what get chain info is going to do is it's going to allow us to look at what the staking denom is for that chain, what the chain ID is, etc. We'll call that in an async manner. Then we're also going to use the Agoric chain object to invoke something called get vbank asset info. And what this is going to return to us in an async manner is all of the assets registered in the vbank asset list on chain, right? So now I can have a reference to what assets are available on the local Agoric chain. So then we're going to do two things you've already seen before. So on line 79, we're going to invoke make account on the Agoric chain object. That's going to make us a local account. Then we're going to do the same thing on the remote chain object, and that's going to return for us a remote chain account. So here we're going to use the same approach again of just waiting for these promises to all resolve. But what we're invoking here, we're using these chain accounts here to asynchronously invoke get address to return for us the actual address of these accounts. Okay, so now let's look at a little bit of magic that we're doing here too. All asynchronously, I might add. Again, it's the keyword of the day, async. So look at line 96. Let's talk about what this is doing. So recall, and actually, why not? I'll just do it again just because we're here. Okay, let's try it one more time. So let's do fun new. Boom. Okay, hopefully universe still with us. Okay, boom. So we got some accounts, I think. Yeah, one account. That's the other one. Okay, two accounts. Boom. So notice this account pops up, the Osmo account and the Agoric account. Notice it doesn't have funds, and now it has funds, right? So there's some sequential steps in there that happen asynchronously, right? So you first see the Agoric orchestration account pop up, it has no funds. Then you see the Osmosis orchestration account pop up, it has no funds. Then you see the Agoric orchestration account has all the funds. Then you see that same account have half of the funds, and it's like the other half disappears. Then the other half just shows up in this other orchestration account's balance. Let's look at what's happening there. So concretely, what's happening here is we are invoking this. This is a convenience method actually in the Zoe tools. Actually, let's just okay. Let's just do it this way. So let's go back. Okay. So what's happening here is what we're doing is we're passing in this seat to a function called local transfer. And then we're also saying who the local account is and the assets that we want to give it. And so what this is doing under the hood is this is using Zoe to create an empty seat and move the funds from that seat to the empty seat. And then that empty seat, it's then depositing these funds into the the local orchestration account. So essentially what's happening here is the funds that are being attached to the offer are then being moved from the offer into the actual balance of the local orchestration account for you. And then that's happening in an asynchronous manner. Then what's happening when that resolves is now we're invoking this transfer function on this local account that now has the funds. And so this transfer function on this local account, what we're doing is we're telling it the denom that we wanted to transfer and the value. So we're just transferring half the funds here. And then we're saying that we want to transfer this to this remote address. But wait, the local orchestration account and the remote account exist on two different chains. So how is this happening? I'm glad you asked. In fact, this transfer function, this is how you use the API, but what's happening under the hood is the Agoric API knows to send an IBC transfer or a local transfer, depending on what type of account that you're using. Okay, so to recap, what we're doing is we're making two orchestration accounts. Then the funds that are attached to the offer, we're depositing that into the local orchestration account. And then we're telling that local orchestration account to now send an IBC transfer to the osmosis chain to this remote interchain account that we made. Then at the end here, we're exiting the offer because funds are done doing what we expect them to do. And then again, we are returning this remote account as a continuing offer. Okay, then once again, you see us hardened here. Okay, and this function here is not completely finished. But I want to walk you through because it's still showing us using the API. And so the difference here, notice we're doing the local transfer and then the remote transfer again. But then here, what we're doing when we want the remote account to, when we expect the remote account now has the money after the transfer using this await, what we're then doing is we're then signaling to we're invoking this delegate function or method on this remote account. But this is pretty much telling the orchestration account on Osmosis, that ICA, to now delegate funds to whatever the validator is that we pass in, right? So what you're seeing is different uses of the orchestration API working in tandem with one another. Okay, all right, so hopefully that makes sense. We have time. Okay, let's look at how the UI is doing some stuff that I think are relevant here. Let's see how we want to do this. Okay, so let's look at some VStorage stuff really quick. So notice in the UI, we have this list here that's populated of these orchestration accounts, right? Where are these coming from? Okay, I'm glad you asked. What's happening here, we have a component here that what it's doing is here we're using this watcher and we're invoking watch latest. But remember we talked about VStorage being dot separated storage paths and hierarchical storage. What we're doing here is here we're passing in what the storage path is that we want to watch, right? And so all that, and what I should say is if you look, so this is a tool, once again, this is, if you're interested, just go to p2p/org.github.io. We could put this in links for you. But this is allowing me, I'll show this in the slides, but this is allowing us to view storage in VStorage. But we can also do this like on the CLI or something. We could say add the query VStorage data, or let's say children, published Agoric names, right? And boom. So we can actually invoke it through the CLI, right? But all this is doing is just sending an RPC query anyways, right? But what I want to show here is if we go to the bottom, there is, let's see here. So we have this storage path here for this orchestration contract, codename Orca. Here, what's happening is the response, every time we make an orchestration account, there's something in the orchestration API known as this facade, this chain facade, which you don't have to worry about. But what it's doing automatically for us is it's writing these resulting orchestration account addresses to this storage path. And so on the front end, what we're doing is we're reading from there to get this list, right? Okay. Let's see. And then I do want to show roughly doing an offer from the front end. It's super simple, right? We have this Agoric wallet connection, which makes things super simple. And you could just import that using Agoric React components here. But essentially what you can do is you can just invoke this make offer here, and then you're passing in what the source should be, the contract instance, and what invitation maker you want to do this with, invoke. Yeah, it's super simple if you're interested in doing that. Let's see. And then let's see. So we talked about VStorage on the front end. Let me see what else is relevant here for you. I think that's pretty much good on the front end here. Okay, so that is the project walkthrough. What we just did is we just walked through the contract and we walked through some UI components here. I will say, so the way we're fetching balances here is just using like Stargate to fetch like the delegations, and we're just like every time you see a new asset pop up here, all this is doing is really just fetch. It's just calling get balances the same way that you would do AGD query bank balances for a specific address. Same thing. Okay. All right. I think that's good. Okay. Let's see. All right. So I think we might have time for some questions, which would be awesome. But here's a recap of today's journey. So what we did is we walked through a demo of the new Orchestration Basics dApp, which you're free to go try right now. Also, I want to throw a tidbit out here. If you're interested in trying this, if you run into any issues, please open an issue and let us know. Yeah, I think that'll be good. And also what we did today is we did an overview of the concepts for building on Agoric using the SDK. But then we also looked at the foundations for using the Orchestration API itself. And if you're interested, there are some docs that you can review. So we have this orchestration overview here. We also have these key concepts where we're teaching you about what are ICAs. I think that's helpful to go look at. We also have another PR that should be landed soon of some more in detail, like contract walkthrough stuff of the orchestration dApp, similar to what we just did today. So look out for that. And I would say, I have to always plug this. Oh, you know what's funny? Right after this talk, so we do office hours every Wednesday, and it's literally right after this talk. So it couldn't work out any better. So for anybody who doesn't get a chance to ask a question or they don't want to be put on spot today, feel free to come to office hours because it's open to the public. We do it every week. It's fun. Have a lot of cool people in there. We learn cool things, teach cool things. So let us know. And last but not least, you can go to our docs.agoric.com. And I think that's good. And I would love to take any questions if you guys have any.
Thank you. That's really awesome. Office hours is a great idea, and it's great that it's right after this session. So if anyone has any questions that they want to go and ask at office hours, could you put the link for your Discord in the chat possibly for anyone?
Yeah, sure. It's actually just agoric.com/Discord. I don't know who set that up, but
people probably will be able to find that. In terms of questions, we did actually have one question in the session. Yeah. Someone was asking about Zoe and whether it's the safer way to write smart contracts. Could you talk a bit about Zoe and how it makes writing smart contracts safe?
Yeah, sure. Good question. And so I think that one thing that comes from this is you have to think about offer safety, right? And there's several times in just regular building smart contracts, if you think about using Uniswap or something, there's many times where you want to call get amounts outs or something like that. We want to make a swap. And sometimes you might get less or more. That's what arbitrage is focused on, or you might get less or more than what you're asking for. And so with offer safety, what happens is you don't have to worry about, as long as you use Zoe, this on-chain service, to escrow the assets, you don't have to worry about receiving anything different than what you are expecting. And also Zoe, it helps with installing contracts. It helps with starting instances, right? So there's a lot of things that Zoe actually helps with, but Zoe was really created by minds that were very security conscious. And so that's actually one of the whole purposes of it. And we have documentation on offer safety too, if you're interested even deeper. But yes, its purpose is to be more secure for developers.
Sorry, I muted myself there. Nice. We have someone typing in the chat currently, so they might be coming in with another question.
Yeah,
I've just posted the link to the Discord that I got
Thank you.
by searching Agoric Discord. So anyone can do it. But if you want to follow that link and go to office hours, if you have any questions about this session, we'll be. Thank you for answering the question.
Of course.
What's being typed?
Honestly, we can do this all day. We love just educating people. And to be honest, when we do this, a lot of people come up with some really interesting ideas that we didn't think about. And so it's very fulfilling for us. And it's just fun overall, right? This is some great technology. Me personally, I love what it is that we built here, but that's just my bias. So.
Your bias, love it. So the recording for this session will be available online tomorrow. So nice. If you want to rewatch any of it, possibly leave comments under it if you have any questions that you don't have, that you aren't pressed with at the moment, but you might have from rewatching, then do that. A couple people are typing, but I'm assuming that it's all thanks in the chat because there's nothing in the questions tab.
Okay.
We'll give it a minute, otherwise we'll end the session here and everyone gets about 5 minutes back of their day.
Yeah, sure. Let's see. Javier, okay, Adam, what are current capable chains? Good questions. Agoric has IBC connections to several chains. You can actually go and look this up, like on MintScan, etc. But there are certain limitations with some chains that don't have ICAs enabled yet. But we're working with a lot of chains who don't have those enabled to help enable them. And this is a function of time too. Like the amount of chains that we're connected to and the amount of chains that are orchestration enabled, I would say, is going to continue to grow. And we are also exploring doing this on the EVM side as well. A little bit of alpha, but can't say anything about that yet. Probably shouldn't have said that. Sorry, G. But yeah, so hopefully that answers that. Adam, any follow-up on that? All right, awesome. All right, so anybody interested, please feel free to come to office hours in 8 minutes. We will see you there if you're interested.
Awesome. Okay, final announcement. Coming up, this is the end of the Chain Abstraction Educate series, but as you probably know, coming up we have a hackathon where we'll have a few more chain abstraction based workshops and of course some bounties. So do check out the hackathon page to find out more about that if you're wanting to participate and register a project. I'll send around a link. You would have got one today, but I'll send another email dedicated to the hackathon with everything you'll need to know if you want to take part, and hopefully we'll see you all there. Okay, other than that, thank you for joining us for this series. I hope you found it really useful and learned some really cool new things about some really cool new technology. And we will end it there and see you in the hackathon.
Thank you, everyone. Thanks for joining with us. We appreciate you. Hit us up.